Everyone. Welcome to the Applied Privacy Podcast, where I invite privacy pros from both industry and academia to come and share their thoughts on the privacy landscape from an engineering and research point of view. The series is called Applied Privacy because there is an imminent need for privacy products to be built to safeguard the interests of customers, clients, and businesses alike. While the government of nations have been doing their part in legislating privacy, I believe it is our job to take the baton and engineer solutions to build privacy into the products and services that we offer. And today we have with me David Burnett. Dave is the head of business development at Zero Biometrics. They design zero-knowledge face authentication solutions that don't rely on biometric stored data. Unlike all traditional biometrics, registration and identification are required to store a biometric template for onward matching. These templates are sensitive, not revocable, and pose risks in the event of a data breach. This is why, I believe, companies have to protect your biometric data, whether on your phone or in the cloud. I'm very happy to have Dave with me. So hi Dave, thanks for coming here.
Thanks so much for having me. I'm glad to come and talk about something that I'm so passionate about, which is our privacy and our data security.
Yeah. So Dave, why don't you tell me more about how you got started with Zero Biometrics? Like basically what I'm trying to ask is that what does the history of David Burnett look like?
Well, I've been in the privacy, identity, security, and biometric space for quite some time, roughly 15 years. A little bit less on biometrics. The earlier work was around security and some identity initiatives. But my technology career goes back almost 30 years at this point. And then I really got passionate about this triumvirate of issues around identity, security, and biometrics, because it's so critical to how we interact with the internet and how we go online and our privacy. And it has so many repercussions across our lives, especially when it's done poorly. So I've been in that field for many, many years. I've worked for companies that make fingerprint sensors. I've worked for companies that make authentication products. I've played a significant role in helping the FIDO Alliance get started, which is a biometric standards and authentication initiative. So calling it biometrics isn't quite right. It's really an authentication technology connecting devices to cloud systems where you can rely upon the remote biometrics that are on the individual device. But in all of these areas of my career, I've always been attracted to hard problems that take teams of really bright and creative people to solve, but more importantly, that have an impact on our real daily lives. Because I remember going way back in my career, I was involved in a product called PGP technology, which was early days of email encryption, and then time at Symantec, and then kind of carrying on. And when I was working a couple of years ago for a fingerprint sensor manufacturer, I made a list of some of the biggest unsolved problems in biometrics and how that relates to our privacy and our identity, our security, our ability to be safe, when we go online. And I'd always had a problem with the fact that biometrics traditional biometrics require you to save a picture of yourself, your face, or your fingers, or your iris, and then take another picture and do a comparison, because that's sensitive information. So for years I'd had on my list of unsolved problems, zero knowledge for authentication. Authentication where your face or your finger is truly a secret, and where you authenticate without the device or the organization that's authenticating you knowing what you look like, or what your finger looks like, or what your iris looks like. And about a year ago, I met the founders of this particular company, which we've rebranded it and we're calling it Zero Biometrics. And they had a solution to this problem. And it was fascinating. And I did a lot of digging into the technology because at first I was skeptical. I was like, wow, okay, someone's actually solved this problem. This isn't just academia research. There'd been some work in academia around some of these problems, but this was a real commercial implementation. And I just got super excited. I got super, super excited because it not only was something that I had known was a problem, it is a ground up rethink of how we do authentication so that we don't need to know what you look like in order to do an authentication event. There's no information stored about you. And it's inherently privacy preserving. And there's some other really cool things that we can talk about because it doesn't just keep your face private. We allow you, because we sit right at this intersection of cryptography and authentication and biometrics, right? Because we sit right at that intersection, we can do things like generate cryptographic keys that are based off of your biometric data. There's a whole host of very, very interesting things that we do. And there's some very thoughtful things around tracking consent, limiting the duration of time, for instance, that your biometrics can be used. Lots of cool stuff, and I'm sure we'll dig into it as we talk.
Okay, perfect. So, Dave, before I jump on to my next question, I have to take this moment and appreciate that I can clearly sense that you are an engineer at your heart. And being an engineer, I can only be excited to have another engineer's opinion. So, and thank you for being here. And I'm excited to ask you more deeper questions. So let's talk more about your company, okay, in specific. So you mentioned it's not only about biometrics, it's more about authentication. And let's talk about in terms of authentication. So what are the key products that Zero Biometrics are proud to have in its arsenal?
Yeah, so we have a product that we call Zero Face. And it is, as you might imagine, it does face recognition without knowing what you look like. But I'd like to back up just a little bit because we describe ourselves in a very different way. I mean, if you go Google face authentication or face algorithm providers, you'll find a dozen companies or 24. There's a lot of them out there, right? We start by saying that we are privacy preserving and data protecting face authentication because that's both inherent in our design. We are very passionate about this issue, and our approach is just a clean sheet approach to authentication that gives us the ability to do all these other things. And then to expand on your question, we have several key features and capabilities within Zero Face that are very powerful. They're tailored for certain use cases like authenticating against an ID card. We do some very interesting things with QR codes for authentication, for offline authentication. They're all technically part of Zero Face, but they are so unique that we call them out and highlight them almost as though they're different products. We also have implementations of the same core technology for iris. We also have implementations for fingerprint, but those are either less popular modalities for authentication these days, or they require a lot of device integration, especially with fingerprint. So our focus, our primary market focus is on the face authentication because it's easy to get it up, it's easy to get it running, and it's easy to get it deployed across a larger population of people.
So let's get deep into the weeds, shall we? You tell me, you mentioned about Zero Face, one of your most highlighted arsenal and tool in your toolkit. So how does it exactly work?
Sure. So it works in a very interesting way. So we use, as you might guess from the name zero in everything, right? We've zero biometric, zero face. You're going to hear zero something many more times as we talk. Zero knowledge proofs are a big part of how we work. And fundamentally, we start with the premise of, how do we authenticate you without knowing what you look like? Which is an interesting problem. Right, and I'm sure we'll talk more about zero knowledge proofs, but the way that we work is that we look at your face. Our software will look at your face, usually embedded in an application on a mobile phone, and we'll look at your face, and we will generate a formula looking at stable features of your face that will describe your face and produce a one-way hash result of what your face, not exactly what your face looks like, but where there's interesting information in your face. And when you apply your unique formula to your face, what would the results of that formula look like as expressed in a hash? That's very different, by the way, than the way normal biometrics work, where they're basically taking a picture of your face, they're vectorizing it, and then they're saving it out. But it's still a reversible thing. I mean, this, you may not know it, but there's been plenty of research articles showing that you can take a saved face template and reverse it back into a photo. Well, we don't save any biometric information. We save, a formula that will describe your face, where to look for interesting things and what that result should be. We save that. We call it a zero map. And then when you come back to authenticate, then your face is compared to your zero map. And if the result of that formula gives the exact same hash output as what was initially recorded, then it's a match. But it has to be exactly the same output. If it isn't, it fails. It's very different, right? Face, traditional face, they take a picture, they save it, they take another picture, and then they do a difference comparison to see, well, how similar is this earlier photo of Dave to this brand new photo of Dave? It's a probabilistic sort of approach.
Yeah, that is actually, I was going to say exactly the word. So basically what you're saying is early approaches is more probabilistic in nature, but a zero face is kind of binary, right? So if it's 100% match, it will authenticate. If it's not, it will deny you the access.
Mm-hmm.
Right. So, so for folks who don't know exactly how these cryptographic functions work, you could imagine like a mathematical formula. Okay, you could imagine a function which it will have some parameters. Okay, so you're feeding into the parameters, and then you're creating a cryptographic, key, so to speak, or you are kind of hashing it. That's what we call it.
We're creating a hash output.
If you
Yes.
Yes. So if you change even a single parameter, even a tiny bit, you will get a completely new hash, completely different hash. Completely different, you could say 256 bits. So I believe, do you use SHA-256?
Yes, we do.
Okay, all right. So that's basically it kind of thing. Right, perfect. So, thanks for elaborating on that. So you have explained like how this thing works. So could you tell me, like, obviously you mentioned about zero knowledge proofs. So how do you explain that? So what is zero knowledge proof in cryptography, and how exactly does it tie into your product?
Mm-hmm. Sure. So zero knowledge proofs are actually really, really fascinating. And I like talking about them, even though I am not at all a mathematician by trade, right? But the idea is pretty simple, right? A zero knowledge proof is a way for someone who has something to prove, let's say me, to prove to you, Aben, that something is true. But I don't want to tell you any of the reasons why it's true. I just want you to be able to be convinced, evidence-based convinced that something is true. And And so if you take that idea, right, I mean, there's a really simple example, right? If you take, like a little safe that has, a slot in the top, and you write on a piece of paper, and something, and you put it in that safe. I can prove to you that I know the combination to that safe by opening it up, looking at the piece of paper, and then reading back to you, right? You don't actually see the combination. There's no new information that's shared. But you are 100% convinced that I know the password to that safe because I've opened it and I've read whatever you wrote on that piece of paper that I didn't know anything about. That's a real simple example of a zero knowledge proof. What we do and the way that we approach things is we want your face to be the secret. We don't want to know what your face looks like. We don't want the software to know what your face looks like. What we want is to have a formula, a zero knowledge proof, that's created to verify your face. And we take that output. And if somebody else puts their face in front of the camera and it's your, what we call a zero map, you're not going to get the same hash result. It'll fail. The only time that you will get the same actual result is if it's my face. But the formula doesn't have any information in there about what I look like, what my face looks like, whether I'm white, whether I'm black, whether I'm from India, or whether I'm from Canada, right? It has none of that knowledge.
So you basically what you're trying to say is that it addresses a very, very important thing known as data or information leakage, right?
Yes, it does.
I won't be providing you anything else except what is absolutely required of you to know.
Mm-hmm. Yes, that's correct.
Okay,
and we've actually. I'm sorry. Go ahead.
No, go ahead.
I was just going to say, and we've actually, because our claims are pretty significant, right? I mean, we're doing really cutting edge stuff. And there's an old saying that says, when you have great claims, you have to have great proof. We actually have retained an outside third party to review, not only the accuracy of our solution, because, I mean, cool that it's privacy preserving, but if it's really lousy and it's how it works, if it doesn't have good accuracy, it's not much use. But more than just the accuracy, but to review the core science behind what we're doing, because it's just so important that someone independent from us, that understands these principles, has looked at it deeply and said, yes, when they say that there's no biometric data being saved or used, we've looked at it. We agree. There's absolutely no biometric data. There's no privacy implication here. Because there's no personally identifying information, there's no face data, there's no nothing. It's zero biometrics.
So it is completely private in every sense of the word.
Yes, it is. It is.
Okay. So you mentioned a bit about the accuracy.
Mm-hmm.
Could be a weird question to ask me. Could you tell me, like the metric that you use, like the accuracy that you're talking about? Is it 99.9%? Is it 1 in a 1 billion? Like, how did you measure the accuracy?
Sure, this is a great question, and there are organizations in many parts of the world that do different types of biometric tests. And the way that there are two things that you typically measure when you're trying to figure out how good a particular type of authentication is, or biometric authentication. First is, how often is it going to mistake someone for me or you, right? How likely is it to see your face and think that it's Dave, or to see Dave's face and say, nope, this is Aben, right? That's called a false accept rate in the industry, FAR, a common abbreviation. And you want that to be very, very low, right? Many of the tests, especially for face recognition, look to see how frequently would that happen over a population of 1 million people, right? So it's usually like, 1 or 2 or 3 or whatever the numerator is over the denominator of 1 million. The other measure that's also important is how often will it incorrectly reject me, saying, yeah, I know, I don't think this is Dave, or I don't think this is Abe, and when it's actually you. That's called the false reject rate. And that's an interesting number, and it's really tied to convenience, right? So, in some situations, if you are doing a credit card transaction and you're doing some sort of biometric authentication along with the credit card transaction, you're going to have to pick that right balance point between accuracy and convenience. And there are many, many factors that different businesses consider when kind of setting this dial between accuracy and convenience. And typically when you set the accuracy really high, the convenience goes down. So when false accept is a very low number, then the reject rate tends to be higher. And therefore the experience of using it is just more frustrating. And so what is so interesting about our technology, and this goes straight to the technology that we use, the fact that it's a clean sheet approach. Traditional biometrics, that the architecture that most finger and face companies use it's almost 60 years old. It's hardly changed. The basic design architecture hasn't really changed in almost 60 years. Our approach, the zero knowledge proofs, the other sophisticated math that we do gives us phenomenal accuracy. Our false accept rate is 1 over 1 billion people. It's just unheard of. The next closest company, and they're super excited and they have every reason to be proud. Their score is 1 over 125 million. That's great. Face ID on an iPhone is 1 over 1 million, right? And so we're at 1 over 1 billion and we don't need all that specialized hardware. So it's not just, hey, guess what? We've got this cool new technology and it's privacy preserving. It's more accurate as well, and by the way, that 1 over 1 billion is at an incredibly low false reject rate. So we have a couple of key things, the key messages, right? We're zero knowledge, right? But we also say we're zero compromise, right? You get a completely better privacy and security profile with our technology, and better performance, and more accurate. And it's pretty exciting. It's pretty exciting stuff.
It is unusual to hear, that you have found this sweet spot between accuracy, privacy, and convenience. It's not very unheard of, honestly speaking. And I don't know, I guess I'm very curious to understand more into the details. So you mentioned about zero phase.
Mm-hmm.
You use zero knowledge proof, and we have understood that zero knowledge proof is essentially proving something without, first of all, you don't need to have the particular knowledge. You can prove certain thing, and you can only prove certain knowledge, so to speak, without having to leak or possessing some other information.
Mm-hmm.
Okay. Now, I guess I'm trying to get in more into the details. How does zero knowledge proof come into the picture when we have to preserve the privacy of users? And how does it exactly tie into recognizing someone without having to store their quote unquote details?
Sure.
You mentioned again, this is kind of paradoxical for some reason.
Yeah.
You don't store data, you don't store facial recognition, yet somehow you recognize it. Okay, it is extremely paradoxical. So Could you help
Yeah,
me
of
out?
course. And this is tricky stuff, right? I mean, on the face, you read, go to Wikipedia and read the explanation for zero knowledge proof. And I know the first time I did it, I was like, that doesn't sound possible, right? I mean, it's really a paradox in terminology, right? And so let's dig into this, and especially how we use it. And by the way, I mean, yes, zero knowledge proofs are absolutely part of what we do, but there's quite a bit of other other algorithms in math and science. A lot of it's proprietary, but there's a lot that's going on under the hood. So fundamentally, I think the easiest way to think of this is that when we look at your face, we identify, some number of places on your face where there's something interesting, right? We don't try to describe what's interesting, right? Or what you see or what we see in those spaces, but we look for, 35 or 40 or 45 or 90. I mean, you can adjust the number for different use cases or security goals that you might have. But we look at those places, we identify them as interesting, they're having some sort of interesting data at those locations. But we don't save what that data is. We save the locations, we embed it into a formula, and then we run that formula on your face, and then we get a hash output that says, let's just say 1, 2, 3, 4, 5. It's actually a SHA-256 hash. That's the output. Then when we come back to authenticate you, we reload the information about where do I look, right? And what's the expected result when I take this formula and I look at these 35 interesting locations on this person's face. Let me take whatever data's there. I don't know what I'm looking at. I'm just looking at these 35 points. I don't know what I should be getting, but let me take it and let me dump it into the formula and see what comes out of the back end. And if it exactly matches, character for character matches what that formula returned when it was my face before, then it's Dave. It's a little bit simpler when we talk through it, but it's still, pretty unusual. And, depending upon the sophistication level or the experience that some of your listeners may have about biometrics, there's a related problem here that we should touch on briefly, which is just really simply, if we took a screenshot of what your face looks like right now, Avon, and just take that picture and shove it into a SHA-256 hash, you'll get a result. I mean, SHA-256 works with any sort of binary data, right? But as you move your face just a little bit, if I take a second picture and run it through SHA-256, I'm going to get a massively different result. So it's not like somehow we can just take your face and shove it into SHA-256. That's just not possible, right? Because there's so much entropy. And even like as I move around here, sometimes you see a little bit of sunlight hitting my hair or my face. If that gets picked up, it's going to totally whack out the result from SHA-256. So there's a necessary thing that we do that's where we do what's called fuzzy matching or fuzzy extracting, right? So when we look at your face, we run a set of additional formulas to make sure that we're compensating for the different changes in lighting and so forth, so that we can be tolerant of the fact that your face data is not the same from photo to photo, or even minute to minute or second to second in this video. As I change my expression, my face changes, and thus my SHA-256 result should change. But by looking at these 35, 45, 55 points, we can become insensitive to some of those changes. And that insensitivity and the fact that we're not doing some sort of picture comparison to match you allows us to take our accuracy all the way to levels that are just very unusual in our industry.
Yes, I actually had missed that point that you mentioned. When you change your face, I don't know how did I miss that, but I'm really glad you brought that up. Um, However, I just have one additional question slash query. You mentioned that you don't store my facial features, right? But I believe you store the cryptographic hash that you get.
The hash output, yes, we do store the hash output.
I mean, you have to do. So, I guess so there was a paper by Andrew Trask. So there are 5 pillars of privacy, he says. I mean, input privacy, input verification, upper verification, and governance flow. Sorry, flow of governance. So, I guess you have massively, with this kind of solution, you have massively uh, solved input privacy. So you are not really taking my face. You don't care about my face. You only care about the cryptographic hash. And while doing that, I mean, you get a cryptographic hash, and while doing that, you are also immune to, let's say, if I'm wearing a spectacles,
Mhm.
glasses, as you call, or if sunlight is falling on my face, stuff like that. Maybe I will shave my beard as well tomorrow, and still it will be able to produce exactly the same hash. And to me, see, honestly speaking, probabilistic model is very easier to understand, right? So even if you share, even if I shave my beard, I will still be able to recognize, yeah, okay, there is an 80% chance that this is
Mhm.
Aben, and these photos belong to Aben, bearded Aben and shaved Aben. But when I shave my face, and if you're still getting that exactly
Yes,
same hash, that is absolutely
yes.
insane. That is
It is.
absolutely
It is.
insane,
And
right?
actually, it's
So,
kind of like zero knowledge proofs. It's so counterintuitive that it really requires some thinking, right? And even though the way we work is not exactly what you would find in a Wikipedia article, there's a related set of research that's very conceptually similar, called fuzzy matching or fuzzy matchers, fuzzy extractors. You can Google that and go to Wikipedia, and there's just fantastic research literature on this. So what's important, I think, especially since we have a commercial offering, is that, okay, yes, it's a small company and they're doing some real cutting edge stuff. And we haven't even talked about how we deal with, recording user consent for their biometrics to be used, or the things that we do to support, what if you only want someone to have your biometrics for a week, right? I mean, there are other really cool things that we do, but there's a strong amount of academic research that's been done into things very similar to what we're doing. And the right way to think about our company is that, we've done a clean sheet design, but others will do clean sheet designs around authentication. And with that clean sheet design, you get things that you never got with face authentication before in terms of racial or insensitivity, right? Because you don't even know what the person looks like, right? So how are you going to be massively biased against people that have a different skin color, so you're not going to have some of those bias challenges. You've got so many security and privacy benefits. There will be more companies that do things very much like what we do over the course of the next 5 to 10 years. And I think the legacy way of doing face authentication or finger, which is that 2-picture comparison, that's going to go away. That's going to be the old way of doing it. Legacy authentication. And it's been awesome that it's gotten us as far as we have, but it's time to stop using an old wagon and to start to use a modern electric vehicle for our authentication.
so are there other ways that Zero Face promotes privacy or data
Sure.
protection?
And in fact, this is one of the things that we're proudest about because, the privacy of our data is under assault. Whether by pure commercial forces. There's the old saying, or now I guess it's an old saying, that if you are not paying for the technology that you use, then you are the product, right? That means your data is the product. So how do we keep our data safe, right? And, frankly, modern phones have gotten pretty good. They're not resilient to, nation state actors. If a nation state actor with some of these advanced cracking programs want to get into your phone, they're going to get into your phone. But the problem in a lot of the devices that we use is, even if there's a biometric layer on there, is that the cryptographic keys that are traditionally used to protect your data are sitting there somewhere on the device, right? To different levels of protection. And some devices do a much better job protecting your keys, the keys that keep your WhatsApp messages safe, or keep your Signal messages safe, or that are used to, encrypt the file of your passwords. Some devices do a great job. Some devices don't do a very good job, or they thought they did a good job and then they discovered an error in their coding, and then it turns out all those sensitive keys could easily be harvested and stolen. So we like to say that, backing up to templates as an analogy, the best biometric template is no template, right? Don't have a template. That's what we've been talking about so far. But when it comes to cryptographic keys, we like to say that the best cryptographic key is no key. Because once you have cryptographic keys on your device, you have to protect them. You have to keep them from being stolen, right? All of the things that we've just been talking about. Well, that's one of the things that we do that is, it's almost weird that it's part of a face authentication platform. Because we're in this cryptographic space and we generate a large hash value result from your face. And yes, I've mentioned that we use SHA-256, but we could do SHA-512. There's other sorts of hash generators that we could use if you want an even longer value. And we can combine those seeds, or those hashes that we generate, with cryptographic key generation processes, so that you can generate any number of keys that you need for different activities, symmetric keys, asymmetric keys, whatever you want, and encrypt or decrypt data. And then when you're done with your cryptographic operations, the keys get thrown away and they don't exist anymore. And so if I've taken my password file and I've encrypted it to what we call, here's another zero for you, a zero key, right? Our zero key branding again, or our zero branding again. We take and we encrypt your password file to all of your personal websites on your computer, on your PC or your laptop or what have you. When that encryption's done and you log out and you're gone, there's no decryption key in the world for your data. Literally doesn't exist. And it can't be subpoenaed. And if you take that file and you put it on a cloud server, they don't have the decryption key to it either. If now all of our modern messaging apps rely upon some key data, but the keys, for messaging exist, or they're negotiated. There's a handful of different protocols that are used to keep them safe. But there's no need to have those keys physically residing on your device anymore. This is a radical new concept. Generate the keys when you need them and throw them away when you're done. Because as long as you come back and authenticate, and remember, we're at 1 in a billion level accuracy, you're good. The likelihood that someone else is going to, be seen by the technology, be seen by Zero Face, think that, that Billy is Dave, and then, get access to my data, it's infinitesimally small. And then we have other security configurations that we can put in place. If you're actually worried about that and you want absolutes, you kind of want two-factor, before your keys get unlocked.
Yes. So it is, to put it mildly, it is a paradigm shift in authentication, right? So, but here, forgive me, Dave, but, I will play the devil's advocate over here. It can't be all hunky, it can't be all roses and sunshine. There has to be some problem potentially. So my question is, do you see any scaling problem with the core concept of zero-knowledge authentication? Or else, what could be the potential challenges if you don't have
Yeah,
these
no.
still.
So, first of all, I think that any company that makes the kinds of claims that we're making should be challenged, right? Because we're approaching the industry and saying we have a radically different way of doing things, and it has all of these benefits and all of these. Just the list of superlatives that we have are pretty amazing, right? And so we deserve to be challenged. So I welcome it from you or from anyone else to be like, how can that be, or why is that safe, right? Those are very, very fair questions to ask. And there isn't, I wouldn't say that there's a scale up problem with our technology. There are things that you do need to keep in mind whenever you're using your face for authentication. And this is true not just for us, but for any kind of face recognition solution, or frankly, almost any biometric type of solution, which is the user really there, or is it a fake? Is there somehow, am I seeing a recording of Dave, and when I go to authenticate or verify his face? It's a liveness question fundamentally. And the good news is there are very good liveness programs out there now and we use some of the industry's best liveness. It's called static liveness, or it's called static liveness. Where it just passive liveness. Sorry, that was the term that I was looking for. It's passive liveness, where it looks at your face, it watches different frames of video, and determines that there really is a human being. It's not a recording. It's not a replay attack. It's not a handful of different things. So that's a challenge, right? But that's true with any biometric system. And if you are going to then do keys based off of your face, then you really need to make sure that you've got the real person there and not some sort of replay attack. Fortunately, we've got a very good answer to that. We've got great technology in that space. But there is a particular scaling opportunity or use case for face that we've deliberately designed our solution to not support, right? We don't want it to do certain types of things, right? And so face authentication on our phone or on a PC, right? That's the authentication market that we're really focused on. There's a whole nother kind of face authentication market that deals with security cameras, right? Doing what are called one-to-N searches, where it's got scans of millions of people, and it tries to see out of, let's say, a crowd of people walking by down a street one day, whether a criminal or a terrorist is walking by. Sometimes these are used in retail stores even. Is this a VIP shopper even? Those are called one-to-N searches, and they have enormous privacy implications. And the last thing that we wanted to do was to take something that was as accurate as 1 in a billion and make it a tool for those kinds of privacy invading scenarios. So it does not work. You cannot use our technology for one-to-N searching at all, right? So that it is designed for personal one-on-one authentication, and it can scale. I mean, we make SDKs for Android and for iOS devices, so it's really easy to add to an application to add that kind of authentication. It can be added to an operating system. It could be added into a web app. There's all sorts of ways to deploy it, but it's not going to do one to some large number of matches.
So my question was more tailored around, when I talk about it. So this is potentially a billion user company. So, I was really concerned, like from a developer's point of view, I was really concerned. Do you think any slowdown in your perhaps, let's say, authentication speed when you scale up from perhaps, let's say, 50,000 users to perhaps 2 billion users? Do you see like potentially? Because see, what you're essentially doing is that you're not exactly storing my facial features. You're only storing the hashes, right? So I guess, technically speaking, if you're only going to store 256 bits, it's it should be able to scale to billion users.
Yes,
But what are
and
your
in
thoughts on
fact,
this?
we've taken a distributed architecture approach where we try to push the compute out to the endpoint device. Many, not all, but many face authentication systems will take your face and they'll send it up to the server and they'll digitize it. They'll do whatever they need to do and they'll do the matching on the server. We've optimized our technology to be embeddable in an endpoint device. It could be a phone, it could be a security kiosk, it could be any number of things. And to have it work just as well when there's no internet connection at all, as well as if there is an internet connection. In fact, our core product doesn't even rely upon the internet. We don't have server-side systems that we call as part of the registration process, which is when your face is seen for the first time, and then the verification process when it's seen a second time.
Okay, that's good. Sounds good. So, Dave, I'm really excited to to have your company and have your product come into market. So, when do you think, like, when are you set to officially launch Zero Biometrics? You mentioned that you're rebranding, so I'm pretty sure there has to be a
Yes.
relaunching kind of thing, perhaps.
Well,
So,
the good
when
news
can we expect
is
it to?
that the ZeroBiometrics.com website is up and running and live right now. We've actually been working in stealth mode. I've been part of the company for just about a year now, and the company has been in stealth mode for a while before that. So it's we've taken all of our information. We've worked with a few early customers as well, and we're launching. By the time this goes live, the website will be out, and I'd say before the end of July, the official press release, with the rebrand and all of the new content, will be published.
That is indeed a wonderful news, honestly speaking, because I don't know, like as a privacy proponent, this is very unusual, and I would love to have your company see, like, I would love to see how your company does, in terms of not only in the valley, but also in the, like, I would want it to reach the other parts of the world, especially India,
Yes. It
Right.
has all sorts of
So,
interesting uses in India, right? Especially as as Aadhaar, increasingly looks at face as part of its whole process. It's and especially they're by policy. The UIDAI does not allow any sort of one-to-end searching on the Aadhaar data set. But it's not impossible. It's just not allowed by policy. With our technology, it's not possible to do a one-to-large end search. So these are some of the benefits and privileges that come from being a clean sheet solution. There's several other interesting things that you can do because our zero map, that the kind of the record of your face formula and the hash result, is not inherently sensitive data. It's not personally identifying. It makes it really easy to push it around to whatever device you want it to be on. So if you normally, let's say you're using it, let's say Zero Face is being used to log you into your bank. Great, and you usually use your phone. But you're over at a friend's house and you want to use their computer to log in. Well, you can push your Zero map onto that laptop or onto their tablet. And when you push it over, you can say, this one's only good for 24 hours, right? Or this one's only good for 6 hours, so that it can't be used when you leave your friend's house. Those are things that we support. Not only just pushing your Zero map to whatever device you want it to be on, but recording, who's allowed to use it, right? Like you can create you have a primary encryption key and you can create subkeys. I can create submaps of my face, and I can give it to my bank and say, here it is, it's specially encoded, you're the only organization that can use this version of my Zero map, and it's only good for 3 months. So when it expires, it blows up, the data's gone, and if they want to, if they want you to continue to do face login, you have to give them a new sub key or a new submap for your face. It's a complete inversion of the whole approach, and it's going to take some time to get the message out that this is even possible, right? Because we think of our biometrics being taken from us, right? That's even how we talk about it. My biometrics are taken. Or I gave my biometrics, it's usually taken. They took a face capture. They did this. Take a picture of your ID card and compare it to your face. We want to flip that ultimately to your biometrics are in your control. This is very much along the lines of, decentralized identity and next generation identity concepts, where your biometrics are yours. Yeah. You have them on your device, and then you give permission to other people to use them on a limited basis with security controls, so that if they have a data breach and their copy of your zero map gets stolen, you can, number one, it's going to blow up in a certain number of time. Number two, if it gets stolen and another company tries to use it, it's not going to work because it's been encoded to just that company, right? And then on top of that, if you need to, you can revoke it. And you can't do this with normal biometrics. And this is the way it needs to work, right? Yeah, this is how biometrics should work. But 60 years ago, we didn't have the science to do it this way, right? And there's been enormous effort put into making biometrics more accurate, especially on the face side of things. But the paradigm hasn't changed. And I defy most people. I have tried really hard to think, where is there a 60-year-old piece of software technology that hasn't been fundamentally re-architected in 60 years, right? I can't think of much that hasn't gone through a major generational architectural reinvention, but we've done it, and there will be others, because the benefits are just too important to not become commonplace.
It is a tragedy that we haven't really updated this thing. And your decentralized approach, where where the facial features, where this identity is not taken from the user, instead security and privacy is given to the user. That is a fundamental, turnaround. You have literally toppled the entire world, so to speak. And I, for one, am very excited, and I am really glad that someone is taking the academic research and breathing life into it by engineering solutions. That is something that I would definitely want to see. Like, I would definitely would want to see, the fruition of your hard work and your company's mission. Now, your thoughts on metaverse? I know, from a privacy perspective. See, personally, I don't know about metaverse enough. Okay, that is my honest answer. And honestly, I'm not very excited. Okay, I am highly skeptical. I know, I'm 25 and already speaking like 60-year-old. Though I'm skeptical and scared of new technologies. But really, in terms of privacy and security, what do you think? Is it a boon, bane, fictional, normal, or paranormal?
First of all, I empathize and understand your skepticism. I mean, I live in Silicon Valley, and I've been here for almost probably about 30 years, living and working in Silicon Valley, and I've seen so many new technologies, the buzzwords. Oh, this is going to be big. This is going to be big. This is going to change your life. If you're working in technology, even if you don't live in Silicon Valley, after even a few years, you see this hype cycle, and you realize that not everything that's hyped is actually is going to be successful. Or even if it is being hyped, and even if it does get some market traction, it's rarely ever as good as people say it is. Now, that metaverse is really interesting because it's, at least the way I think of it, and I may not be completely well informed about the metaverse, but it's as we look to go into, virtual reality, augmented reality, all sorts of different ways of working, that are enabled by technology, we have at the very beginning a decision to make about our privacy as we interact with each other on the metaverse. How do you know that I'm really Dave? How do you know that I'm not somebody else? How do you know? How do you keep your data safe, your private data safe? And so I think there's a very important opportunity, and I'm really glad that there are so many people thinking about this around the metaverse. How do we embed privacy? How do we embed anonymity? How do we protect that? Because frankly, there's all sorts of commercial forces at bay that really just want to use every little twitch of your body and keystroke as some sort of data mining, profit center that subsidizes the cost of the hardware that you're using. So this is the time, right? And
Yep.
Even though sure you can use our technology just as a kind of a one-for-one substitute of today's face authentication systems, and that's great, right? It's more accurate, it's fast, it's got all those benefits. We think that the kinds of capabilities that we offer have to be stitched in at a conceptual level into what's going on with the metaverse. There has to be privacy around your biometric data. When you allow yourself to be authenticated, it has to be with your consent. You have to have, that has to be recorded. There should be penalties if people use your biometrics without your consent or knowledge. Just all of these kinds of things that we've designed into our solution. You should be giving that permission, not having it taken from you. And that's the opportunity. And if we don't do it now, if we don't do that early on, before the rails get too deeply set, we could have a repeat of the problem that we had with biometrics, where we had a model that worked reasonably well for 60 years and no one really took the time to reinvent it.
So would you give this mental responsibility to perhaps Meta or some other corporate or conglomerate, or how would you want this meta, even if it is coming to fruition, how would you want this metaverse to come into fruition? Because Meta has seriously proved that they are incapable of preserving the privacy of people, no matter how they market. At least in the light of previous events, they're trying really hard to rebrand themselves as privacy oriented company. But how would you answer?
For companies that have been in the business of making money by monetizing your data, this is a very hard problem. And it's not just Meta. There's lots of other companies that we work with every single day, and how they pay the bills to give you the products for free or at a discounted rate is by aggregating data about you with other people, hopefully keeping it anonymous, but not always, and then selling it. So you've got a fundamental paradigm problem, right? What I would say is, when I saw the first smartphones, and they happened to be Apple phones, right? The first real smartphones, I wanted it, right? I didn't care what it cost, right? And I think, if whether it's Meta or any other company, if you've got a really great product, you should be able to charge money for it, and you shouldn't be worrying about monetizing the user data. So I think you have to really go to basic principles. How are you making your money in the metaverse? And if you're making money by selling data, then trying to shoehorn privacy into that, there's always going to be opposition and tension. And frankly, privacy is always going to be watered down in that scenario.
That is a good answer. Yes. Finally comes down to
and then there's a
model,
whole other issue, right? Which is not. We need another hour to get into it, and which is when there's a broader privacy risk that happens when you've got all of this corporate data around us, and then governments want access to it for one reason or another. Sometimes it's a legitimate reason why they want access to it. Sometimes it isn't a legitimate reason, and they still want access to that data. So there are real challenges when corporations aggregate enormous amounts of private and sensitive data. We're obviously just one piece of a very large puzzle of solutions to that, but we do think that it's really important to be able to, authenticate yourself without having, pictures of yourself being used as part of that process. That's one part of the privacy preserving. And then greater security around your data by encrypting your data with, a zero key derived from your face, and then deleting it when it's not in use. So that you don't have to worry as much about, is this device that I'm using, is it storing keys securely? Can someone break into it and steal the keys out? How easy or how hard is that to actually do?
So, Dave, to conclude this podcast, if you were to finish your autobiography with one sentence,
this is a great question. God, thanks for asking it. So I really like making things, right? And it can be technology things. That's part of why I've always kind of tended to be with startup companies. I've worked at some larger and public companies as well, but I really love being at startups because you get your hands dirty, you get right into the meat of what's going on. I also like to make physical things like artwork and sculpture and stuff like that. So that last sentence of my autobiography would be, he died doing what he loved, making things with good friends.
That is something, man. I mean, very good answer, very inspirational. And Privacy Pros, that was Dave with us. So once again, thank you so much, Dave, for coming here, sharing your thoughts. And I really wish...
Thank you so much. And thank you so much for having me. It was a delight. I've really enjoyed talking with you.
Cheers.
Cheers.
Cheers.